I want to focus on working with larger volumes of data and, larger tables, high volumes of data and more formal Power BI projects. And, I have a lot of thoughts about this. There are certainly a lot of opinions and consensus around best practices in the industry. But for this, I really wanted to talk to some colleagues and get their thoughts around what works and what doesn't work and what has their experience been as they've tried different things. And so I'm actually going to be talking to and interviewing some of my colleagues who have successfully delivered projects using large volumes of data. And to get started, we're going to talk to Edwin Davis and Alex Beech, who have just finished up working on a large project for a consulting client where they were importing and working with over 1 billion rows of fact data in a Power BI model, and wanted to get some of their thoughts and their experiences as they work through some of these challenging issues.
We essentially were working with a company they had retail stores for grocery store chains. So they would, every time you scan a product, that data or transaction would get logged, and they would call that the T log. So every can of corn, so from a couple of hundred stores, all the transactions from each day. So that was the nature of the type of data. From a fact table size, we were looking at approximately a billion rows in terms of the size of that fact table, going down to all of the transactions for a given point in time. Structuring that data to load into a MPP architecture, SQL data warehouse, or Synapse environment, that's a different thing in itself.
Sure.
And then from a reporting standpoint, they were using Power BI.
The issue that we came across was that one report that required that billion row table. When we wanted to use incremental refresh on it, and when we tried to incremental refresh against the data flow, that didn't work. So for that report, we actually pulled straight from the data warehouse and tried to do it in that manner and put incremental refresh on it to address the volume of it. That's right. They wanted to see this Power BI report before the data warehouse was finished. So the report that we delivered, we built aggregation tables within Power BI on them from the data warehouse. But if I'm not mistaken, it only had about 300 million rows in the data warehouse at the time that we delivered the report.
So in this big fact table in the Power BI model, how many columns are in this table?
If I was to have to think about, it was more deep than it was wide. Being a fact table, it's mostly numerical data, so we're talking no more than about 15 columns, but highly numerical and very deep.
Yeah, we had the aggregation table. I think one was imported, one was aggregated, where you could run queries off of the aggregated table. But if you ever needed something at a kind of a higher granularity, it had that. It had the full table in there as well. I could push those back to kind of how I understand that.
I see. Okay. Well, regardless, you were still importing a very large volume of data.
So we tried, connecting to it through direct query, and even with that, the rendering times for visuals, for slicers, all of that was it took way too long to where it was user friendly enough to where they would even want it, right? I mean, when you're having to wait, I think I timed it. One of them was like 1.5 minutes. It was taking for a simple sum to render on a data card when you put a filter on. So, and then when we tried to pull it in, we were getting errors just because of the simple size. We didn't have enough room. It was too big, so the memory couldn't be pulled in. So when dealing with big data flows seem to kind of be redundant, right? They don't work together very well, is what I noticed. some other things. The data was prepped very well. Edwin did a great job prepping the data, so there wasn't a lot with the modeling or any like things like that I had to do within Power BI. But those are some of the things that are coming to my head now that we dealt with.
Being a data warehouse developer, oftentimes my thought process is a semantic layer, and dealing in the world of databases and your semantic layer. In this case, Power BI seems to be moving towards trying to be that semantic layer, but there's still Azure Analysis Services. And my question would be, Azure Analysis Services, its big selling point is that you can suck in that data model that you get from your data warehouse, and it's now all in memory, all aggregated and compressed. So now when you hit that pre-aggregated model with your reporting tool, be it Power BI or some other tool, you've already got all of your data pre-aggregated, compressed, and optimized. So huge volumes of data can be managed very easily in Azure Analysis Services. Is Power BI at that same level of robustness?
All right, so some of the takeaways from this discussion with Edwin and Alex were that, first of all, they worked with both analysis services, Azure Analysis Services, and Power BI. Ended up working with Power BI in premium capacity. They also experimented both with data flows and regular premium data sets in premium capacity, and ended up not using data flows primarily because they had already architected a formal data warehouse. And they found that some of the features of data flows, although data flows are perfectly capable of handling large volumes of data, particularly didn't have a real good experience with incremental refresh and data flows, and had a much better experience doing incremental refresh and then eventually manually building partitions in the Power BI data model itself. Well, the next set of discussions that I had was working with Brad Jerrett. And Brad has a background in analysis services tabular. And so he's worked primarily with both on-premises analysis services in tabular mode and also with Azure Analysis Services. And he shared a number of thoughts around how he approaches large projects and how he wrangles large sets of data, managing performance, doing testing. And so let's check in with Brad.
So one thing I always like to do, right, when I build any kind of model, tabular in analysis services or otherwise, I like to give myself some statistics, right, about like how many tables I have, how many fields are in each table, how many columns are there, how many measures I have, what those measures are, so I can just get a good feel for how big this thing really is.
Sure, get the lay of the land.
Yeah, and so that's what this workbook is. So basically, what I did is I just ingested the JSON into this Power BI, and then did some Power Query to get my fields and stuff, right? So that's all this is, right? It's cool. It's just a JSON extract.
I love seeing Power BI used to manage and get information about Power BI.
Oh yeah,
it is so cool. It just really accentuates the strength of the tool.
Yeah. So one of the reasons why I wanted to show this in this large scale discussion is so you can see exactly how big these tables are, right? So like if you can see my sales order table, right, has 321 different columns, right? So super wide table. So you can see how wide these tables are, right? So like sales order, obviously pretty wide, right? You can see I've got 67 different measures and 254 distinct columns, right? So I mean, obviously there could be columns, there can't be columns with same names, but the idea here is that this is just a super wide table, right?
Okay, and so just a question on that though. So when we see models developed by, maybe professionals who have a background with relational databases that tend to be very wide with a lot of columns. Mm-hmm. sometimes the thought process is, well, I don't really know what columns I'm going to need, so I'll just put everything into my tabular model. So what are your thoughts about that kind of thing?
Yeah, I kind of I can appreciate, building for the future and trying to anticipate, those needs, right? But at the end of the day, you should only have what you're using, right? Because the idea here is that you want it, like, I tend to use the best product for the job no matter where that is, right? So like, I know that the Vertipack engine that's behind analysis services is really good at aggregating things, right? So like, it's really good at performing those DAX level functions that may aggregate some value or some value or perform some type of row operation. Like, I know that engine's really good at doing that. So I want to move that workload to that tool, right? So basically what I end up doing when I build the actual table or view in this case, because I will only ever ingest views into analysis services. I don't like to ingest tables, just because I think that like the materialized view that exists out there is a lot more performant and you can make changes to without changing your underlying data structure. So I like to use the view.
Yeah, and so it gives you a level of abstraction that can give you a little more control.
And you can kind of separate the two, right? Especially if you're using your tables for other things. So like if you said you had 100 columns in that table, I'd chop it in half, right? And then if you had 10 that you were sure of and 20 that you weren't, then add all 30 in. How can I get rid of some of my slowly changing data, right? And pare everything down to what that fact needs to contain. The processing time that it takes to process each one of those rows is significantly, like, orders of magnitude smaller when you have fewer and fewer columns. So like if you had a table with 10 columns and 1 billion rows, it may process, I don't know, 500 million records a second, right? It could go really, really fast, right? Especially if you have your data types correct, you're not using a bunch of floating numbers, you're not using a lot of date time, you're not using a lot of weird, stuff like that, or strings, that go on forever, right? Things can really get really compact and nice and processing really, really fast, no matter how many rows you have. Now, as far as like the size of your in-memory cache, like the maximum size you can get of analysis services is like 400 gig of in-memory cache. So if you're processing the entirety of the model, right, the maximum model size you can have is 200 gig, right? So you really got to be, and the way that I attack this was with partitioning. So you got really good at, time stamping certain records, creating those small partitions that only process what you really need to process each day, and that's how you can have like a super large model that refreshes super fast every single day, or every how many hours, or how many often you want to do it. So partitioning is a huge deal. There's two ways to look at this. One is that my daily refresh, right? So like my daily stuff that's changing, I'm going to process specific partitions. I'm only going to look at certain records, and I'm only going to process those things. Like I would eliminate my data inside of the analysis services instance and then sort of use like I call it the fill the cup method, right? So like you start with an empty cup and then you fill it full of whatever your oldest partition is, right? And then you fill it with the next partition and then the next partition. So you're not really duplicating your processing each time. You're starting from nothing. Right. That's the only way that you can like fit all of that data in one place, is to do it sequentially like that. So, I mean, partitioning is huge.
Yeah. Just partitioning as a concept, I think is important to understand. And, we can do really simple partitioning schemes. You can take a table, break it into 4 pieces.
Yeah. I mean, what I'm showing right here, right? These are all just time, right? I mean, and the way that I approached this was looking at a particular, like looking at today, right? And saying, hey, I want to process everything in this current year, right? And then on the weekends, maybe I would do like years 2 and 3, right? So a year ago, 2 years ago, and 3 years ago. We had policies, just like you're saying, right? That were called document retention policies. And if they had anything to do with checks or anything to do with contracts or anything to do with whatever, it had a specific, 7-year, 10-year, whatever lifespan, right? But one thing that we lacked, right, was a data retention policy.
Right.
So when we say when we say documents, we mean actual hard paper, right? But a lot of companies miss on the data retention policy. How long should you keep data? When should you forget data? And I think a lot of the recent upcoming, legislation and changes at the state level or country level, where you have these, rights to be forgotten, right? Sort of like the GDPR regulations in Europe, So when somebody asks, right, that, hey, I want you to eliminate all trace of me, right? You need to be able to do that, and that's a really hard thing.
It is
for a lot of companies.
You have a pretty deep background with on-prem SQL Server analysis services, as I have in the past. But as we're, moving a lot of our enterprise solutions from analysis services to Power BI, given that Power BI is kind of growing in the enterprise space, would you continue to use Visual Studio and SQL Server data tools to do your model development?
I mean, we've talked a lot about how the Power BI, like the Power BI modeling, so first off, everything that you're doing in Visual Studio is just a GUI to edit the BIM file. Right?
Sure.
So Tabular Editor is just a GUI to edit that BIM file, right? So I mean, you're still editing the same underlying code base, right? So you're still looking at the JSON, right?
Sure, but these tools are not necessarily just editing, XML and JSON. They're using the tabular object model and actually, calling APIs.
Sure.
And
yeah.
So it's more than just a fancy text editor.
Yeah. The reason I start, and yes, I completely agree. These tools are unbelievable. What Daniel is doing with Tabular Editor is beyond me. That's super awesome.
Absolutely agree.
Yeah, but the reason I bring that up is because we're starting to see this merge, right, of the Power BI modeling engine and the analysis services engine, right? So you're starting to see Power BI kind of swallow up analysis services in a way. To be honest, I'm not a huge fan of Visual Studio. One, because it's a resource hog. It's a massive program.
Yeah.
And it takes a long time to do things, right? But at the same time, the reason it takes a long time to do things is because it crawls that entire JSON and changes the values. So like if I change the name of this column, right, like from last ship date key or whatever to just last date key, right, it's going to go everywhere that particular column exists and change that name, right? Whereas in Tabular Editor, it's just going to change that one line in that JSON. Additionally, I can hide, you can hide things with perspectives. But the reason I wanted to pull this up is twofold. You saw how long it took to open it up, right? And all I'm doing here is clicking checkboxes, right? So like if I want to open this up, right, you can see how long it's taking just to even render everything in that field list, right? And you can see like the things with the little stars next to them means that they're hidden, right? So this kind of gives a little bit of a good, see now I passed it. But like you can see how I've got checkboxes in here in some cases.
And so the designer, as I understand, is having to scan through and modify several lines of property definitions in that model.bim file.
Yeah, exactly. So now the reason I picked perspectives is because if I were to edit this particular model.bim file using Tabular Editor, right, it's lightning fast, right? Mm-hmm. But the reason it's fast is because it's not going and changing it everywhere.
So my third discussion was with my colleague, Kirill Perian, and Kirill is currently working with a consulting client who have already made the decision to use direct query against a large volume of data in their Power BI model, and a fairly high fidelity and pretty busy dashboard style report. They're having some serious performance issues with that dashboard style report. So Kirill has done some performance tuning. He's done some analysis against that data model and has learned some very interesting things, taking a very pragmatic and scientific approach. You're working through a performance tuning exercise using a fairly large set of data. And can you walk me through a couple of things that you found that are performance challenges? And let's talk about some ways that we can approach fixing those.
I have had to count almost the number of elements that are there, and they're not all visible either. So I've counted over 100 elements, which I think is the first conversation you need to have with the client, right? In terms of, do you really need, how many decisions are you going to make just by looking at this, right?
Yeah, just one really, really crowded, busy dashboard.
And
report.
there's definitely, good conversations to be had about that. And there's definitely strategies to avoid all that, right? Because every element on the page is competing for refresh time. So when you get to this page, sometimes they can be grouped together and be performed in unison, but a lot of times they kind of wait for each other, right?
And so, how long is it taking for this page to render?
Normally about 20 or so seconds on the first load. Now there's caveat, not everyone is looking at everything, and I think they're limiting it to a specific project, but this is kind of the worst case scenario in aggregate, right? Where the formulas have to work the hardest. But I think the first layer of approach is to have this conversation about, do you really need all the elements on this page? Can it be separated between different pages? Or at the very least, you can build a functionality with bookmarks where you, for example, if you look at one set of elements here, right, and then you want to move on to a different set of elements, it'll be a button that you could click, right? And then at least it's not forcing everything to load at once.
Right.
Okay. So that's one approach. The second approach is literally turn on the performance analyzer, right? And go to a blank page, or what I found works the best is to really create a blank page, point your cursor to it, select it, make it invisible, then actually close everything, right? Save the file, close it, and then open it again. Then it opens on the blank page, and then you can really tell that you don't have anything cached. And then go to the page that's, that you want to see how it performs. So performance analyzer, you go into view and you click on the performance analyzer, and ordinarily you would go to the blank page, open on that page, you start recording, you go to the page in question. I wait for everything to kind of finish up, and then I go and have to resort it descending, and then also by the total time, right? And then you can.
And there we're seeing, because these are in milliseconds, we're seeing like your first visual at the top is taking about 22 seconds to load.
That's correct. Yeah. So and then you can take a look and see how things, what is actually taking the longest time, right? And in this case, looks like this visual specifically, and this is a, looks like a clustered column chart. So the DAX is not good, and part of it could be direct query, and then it's also waiting for a bunch of, the other is categories essentially waiting for other visuals to do something or to perform some other action. So it usually has nothing to do with this particular visual. It has to do with the compoundness of all the visuals on the page.
Yeah. Now, so this is a composite model that has a lot of direct query tables in it. In fact, most of the tables are direct query.
So
just to recap, from what I understand, there was a performance problem using distinct count. So you used a different technique in DAX to try to improve performance, but because you had mixed mode tables, one in import mode, one in direct query mode,
Right.
that DAX summarize function doesn't work. And to fix
Correct.
it, you went back to direct query, and now we're back to a performance problem again.
And now it actually, the whole thing kind of made it worse. Yes.
Yeah. So caveats of using direct query is there's just certain DAX functionality that either performs very poorly or just doesn't work at all.
Just doesn't work at all. Correct.
What are your, so the customer in this case had a very specific reason that they wanted to use direct query, and it was against a not a huge volume of data, but a fairly substantially large set of data. So what are your thoughts about the decision to use direct query versus import mode?
Honestly, from what I'm seeing so far, just being very pragmatic and going at it from the perspective of, okay, let's improve one visual at a time until we've exhausted all the possible options that are either a visual consolidation or improving the DAX query.
Yeah, well, that's a long time for a visual to load.
Yeah, absolutely. And so I'm going to go back and kind of have a conversation with the client about potentially building a prototype using the import mode, unless there's some very, very specific case that they need a direct query to stay, and obviously if they're willing to live with the consequences of performance.
Some takeaways about my discussion with Kirill about his project with his consulting client was the big question about whether to use direct query or import mode. And, the argument that we need to see data as it's updated in our database, we want to see that near real time, is an important question, but we also need to talk about what near real time means. Do we need to see a record after it's inserted, or, what's the refresh window? Is it an hour? Is it 4 hours? Is it 15 minutes? Again, there's still a good argument to be made for import mode being the natural fit for Power BI and Analysis Services Tabular. It performs better, it's easier to manage, and there are DAX calculations and techniques that really only work against in-memory import mode against Vertipack than they do against direct query. But if you really need to be able to, let's say, drill through to details and be able to see a record that was just updated or imported within the last few minutes or within the last hour or a couple of hours, then there's a good argument to be made for having a direct query version of a table, maybe the details of that table that you can then drill through to, and still depending on aggregates and in import mode tables to be able to provide summary information. So big questions there, and lots of room for discussion.